We have a crate. That is a little larger than I was expecting. Let's start seeing if we can get this crate opened up. Conveniently for me, the top panel was already arrived halfway off. So yeah, we can get this off easily. This welding cart's on wheels, so I think I'll just take off one of these front or back panels. That way we can just roll it right off. Okay. Okay, we're all opened up. It looks like there's a couple leveling feet here I need to raise up so that it can roll. All right, I think that's as high as that's gonna go. Let me see if I can reach the back one here. Okay, let's try rolling this off. I was thinking I'm just gonna use this as a handle to roll it off the crate here and lift. But I realized when you lift it, it just opens the top door. So that's not gonna work. So on reconsideration, I think I'm gonna try to take it off the front of the pallet. That way I can hold on to the black bars there to lift. All right, there we go. Okay. All right, let's take a look here. Skyfire sent me their Mobile Weldstar Aqua model. It's got an integrated water chiller and a 2000 watt laser source. It can be used for laser welding, laser cleaning, and laser cutting. Looks like on the top here is the controller. And then this back panel. Oh yeah, the laser source and the integrated chiller. Okay, awesome. I really like this cart. I'll be able to put my gas canister right on there, so it'll be nice and convenient. I'm assuming this box here is probably the wire feeder for it. So let's get that opened up. Yeah, it looks like the wire feeding machine. So it looks like this is gonna sit up on top here. Something like that. Let's get this handheld cutting head opened up here and have a look at it. There we go. Okay, cool. Oh, that feels really comfortable. The handheld laser model is a Super Laser Cut SUP21T. Looks like it's got a long power cord here that I'll need to get a plug installed on. We got some tubing for the gas, ground clamp, and wire. I bet this cable's probably to hook up to the wire feeder. We got some keys. What do we got here? Well, I don't know yet. We'll have to open that up. One more package down here. Let's see what this is. It's an angle bracket. Well, I bet these are to secure the wire feeding machine on the top. I noticed there were some mounting holes up there. So we'll check that out in a while. Let's see what kind of goodies are in this bag. Safety glasses, it looks like. Some wrenches. I'm not sure what this is yet. Let's have a look here. Some more tools and some tips for the cutting head. Lens wipes. Okay, some different cutting nozzle types. Nice. Some extra lenses. Like a couple different wheels for the wire feeding machine. The tube that we need to hook up to the laser head for the wire feeder. All right, cool. So who knew you could order gas off Amazon? I had this 125 cubic feet cylinder of argon delivered, and let's get it open up here. Well, maybe I should open up these clamps here to get it ready. It looks like there's enough space here to fit a 300 cubic feet cylinder as well. I wanted to go a little bit smaller just because they're so heavy to manage to move them around. Also, I chose to buy my own new cylinder this time. You know, dealing with air gas is expensive, so hopefully it'll be way easier and cheaper to get this refilled. I've relocated the laser welder over into my workshop area, and my regulator and a few other accessories have arrived, so let's get this opened up. The listing for this regulator looked like it came with a 1/4 inch barb for the hose, but it didn't, so we'll have to wait for that to arrive tomorrow to install. It's the next day, my fittings have arrived, so let's get this installed. The machine came with this little piece of tube. Then this little piece of tube should go right into this quick connector. All right, cool. Our gas is hooked up. I've got some distilled water and antifreeze, so let's go ahead and get the chiller filled up here. Looks like we're right at the top of the normal line. I turned on the chiller to let it cycle the water through, and the level dropped down a little bit, right to the middle of the normal level, so that should be pretty good. Let's install these 4 L brackets that are meant to keep the wire feeder in place here. I'm just gonna kind of line it up and then I'll lift it off. All right, I think all 4 are in a pretty good position. All right, that should work. I don't think it's gonna go anywhere now. Let's go ahead and plug in the wire feeder to the main controller. I got a plug attached to the power cord. This is to plug into the 20 amp circuit in my garage. 20 amps is the largest circuit that I have, so I don't think we're gonna be able to run this at full power at the moment. I need to get my electrician out here and see if I can get him to put in a 30 or 40 amp circuit in my garage here. I've plugged it in. Let's see what happens when I turn it on. All right, it looks like our controllers have powered on here. I think I'm gonna wait to dig into this for a minute, and I'm gonna finish getting the wire feeder all hooked up to the laser. The wire feeder came with this tube that's gonna feed it up to the laser head. So let me go ahead and get it attached right here. I'm gonna slide it in here as far as it'll go, but not so far that it interferes with the roller wheel here. All right, cool. Let's route that around to the laser head. I've wrapped this tube around here, so let's attach it to the laser head. All right, let's put a nozzle on here so we can kind of see where to position it. I've grabbed a random nozzle and it looks like a focusing tube. There's some lines on here indicating the focus, it looks like. 0 to 10 and -10. So let's install this on here. Just set it at 0 right now. My nozzle will just thread on the end here. It's also got this little extension tube to feed the wire right up to where you're welding. So this should go in here. All right, let's try something like that. I bought several different types of filler wire that I thought I'll probably want to use.
And you might notice a problem here. This is apparently designed for larger spools. So I think right off the get-go, I'll probably have to design a little mount that will hold my small rolls down here. Something like this.
I threw together a quick design in Fusion, so let's get that 3D printed.
Alright, I have my little spool holder. Got a shaft with a couple bearings in it. Alright, something like that should work. Then I can just drop this right inside here. It has this opening on the bottom. I don't know if you can see it, but there's some bolts sticking up here, but so I can just set it right over one of those bolts and it will kind of keep it in position so it can't go forward or backwards. I'm getting set up here to do my first test weld. I've put in some ER706 wire here. Looks like I need to switch out these feed roller wheels to be 0.8 millimeters. They're different on each side. This side says 0.8. All right, well, I just figured out why this has a tensioning system to keep it from rolling. The second I released the wire, this started to unspool. So let me come up with a little tensioning mechanism so it can't spin freely.
Round 2, I've modified my design to add a tensioning mechanism.
Here we go. Now I've got a little spring-loaded tensioning mechanism so the spool doesn't spin so freely. So let's test it out. Let's see if we can feed this wire through. There's a manual wire feeding button here, so let's try it. Okay, looks like our wire's at the end. I'm ready to do my first test weld. Got the laser on and I got some parameters set off of a guide to get me started.
Here's the guide that Skyfire sent me. It's a good baseline for starting parameters. From there, you just have to test it. I find that usually I just need to slightly modify the power level and in some cases the scan width.
To set the parameters, we just hit this technology button. The guide said we need 700 watts, so put in 700. And everything else is already correct. So we'll just hit save and import and return. Okay, that looks good. Now we can just arm the laser and the chiller. I've got my ground clamp just attached to my table. I've got a little disc here of 2mm carbon steel. Wow, that was really simple. See the back side. Let's see if we can attach these two together. Wow, look how clean that is. That was pretty good beginner results.
My electrician came over and installed a 60 amp outlet so we can run this laser at full power now.
And I've wired up a bigger plug.
I don't think I'm going to weld any more test pieces like this because they're already all over YouTube. Let's jump right in and start trying it out on some projects.
I got this larger spool of wire of ER70S6. Let's get this installed. Let's change this up to 2000 watts.
The bottom plate of this part I'm trying to weld is really warped, so I'm attempting to weld half of it and then use the clamps to press it down flat to weld the other half. Well, here's my first welded part. The 2 kilowatt laser welder is supposed to go up to 5 millimeters thick carbon steel. This is 8, so I was really pushing it, kind of getting a feel for it. See, I cut my angle pieces a little too long. I'll have to grind those off. But yeah, pretty fun for my first try. There's what it's gonna look like installed. I had an incident with a stuck tool, and the machine ripped it through all the other tools until it eventually cracked this Y casting. So this is my temporary fix until I can get that resolved. While we're on the subject of my CNC router, I'm so sick of cleaning up chips every time I use it. So I want to build some sidewalls to help contain that mess. I came up with a design in my head, and I've cut some aluminum extrusion to length. So yeah, let's try testing welding some aluminum. I'm going to be doing a lot of these 90-degree joints, so I set up a test piece here so we could see how it performs before we do the real thing. I put in all the parameters according to the parameter list that I got from Skyfire for a good starting point. And I put in my aluminum wire, so let's give it a try. Well, it looks pretty good, but you can see it's kind of dark. I believe I'm supposed to be using nitrogen for the assist gas for aluminum, but I don't have any at the moment, so I'm still using argon. Let me wire brush it and see if it cleans up. Oh yeah, that looks really good. Let me spin it around here so you can see it better in the light. Looks like I stopped a little short, but yeah, I'd be happy with that. Let's do it one more time on the other side. Alright, that looks pretty nice to me. This is the actual nozzle I'm supposed to be using when doing flat sides. So it can sit like this and then drag. I just discovered that my wire isn't actually feeding. I've been having a really hard time getting this thin aluminum wire to feed through here without binding up and balling up back in the feeder. So what I'm doing here is with no wire. I switched nozzles. Let's try to do this flat side here. I burned it out a little bit there at the edge. The two sides are done. They turned out not too bad. The longer I went, the better I got. I definitely want to get some heavier gauge wire next time, that way it won't bind up. Editor's note, I was doing some research on the Super Laser Cut website and discovered I was trying to use the wrong type of filler wire. What I'm using is too soft. They recommend a 5 series wire, so I've ordered some new wire for my next test. Okay, all the panels are welded on. I struggled at times, and other times it went easy. This is probably the best looking one, and it's not bad. With a round nozzle and having this little edge to sit it in to keep it straight, I'm able to get much better results. There's kind of what it's going to look like. I just welded on these smaller C channels on both the sides so I can put a piece of acrylic in there that can slide up and down for excess. And then I'm just waiting on some 300mm bellows that'll slide through there. Got to make a couple minor modifications like shorten the drag chain and stuff. I'm losing a little bit of cut area by doing this, but it'll be worth it to not have to clean up the mess since I'm mostly using this for cutting aluminum plate. I also have plenty of work area. This top frame was just screwed on, that way the whole thing can be disassembled and removed if I need to. So I bought this auto darkening helmet that has the laser safety glass integrated into it. But I have to admit, I've not even actually used it yet. I've just been wearing the safety glasses. I find that it's not near as bright as traditional welding, so I feel very comfortable just wearing the glasses. Let's try out the laser cleaning function. To get there, hit this button up here. Ask this to restart. All right, we're in a different software layout here. Let me grab some scraps and let's test it out. First, we need to remove this welding nozzle. I've removed the wire feeding tube as well. I've turned the power down to 300 watts. I've got a rusty angle iron here. Let's try it out. That is pretty cool. Look at the difference here. I've spun it around. Let's try cleaning the inside here. Let's see if it'll remove the paint off this old saw blade. I have this old square that's really dirty. Let's see what happens. There's a dirty side. Flip it over. Yeah, that works really well. I almost wonder if I'm a little bit too powerful. If I stop it all, you can see it'll leave a little mark, but otherwise it just cleans it right off. That is pretty cool. There's even something I never noticed. There's actually a ruler on here, and I couldn't even see any of the markings before. Oh, that's funny. Let's also do a quick test of the cutting function. I'm back here on the welding side of the software. Let's go to technology, put the scan width to 0. And I'm going to be cutting 2mm carbon steel. So let's go maybe like 700 watts. Let's try that. You can see I've added the cutting nozzle. Let me put on my gloves here and we'll try cutting out this 2mm carbon steel. Well, it cut just fine. There was just some slag on the bottom there that was holding it together. I believe I should probably be using nitrogen. I don't really have much gas pressure, so it's not really blowing that out of there. But yeah, I could see where that could come in handy, like maybe cutting down some scrap parts after laser cutting or something. Let's try this again. I was digging around in my scrap fittings drawer and I figured out a way to connect my compressed air. So now it's at about 175 psi. Before we were only at like maybe 20 psi. So let's see if it'll cut through this now. Oh yeah, no slag that time. It was just attached where I didn't cut all the way through on the end. All right, cool. So I've been using this machine for a couple weeks now, and I've got to say it's pretty cool. I was using this little flux core welder before, and it was really a struggle to get good results, and everything was so dirty. But I feel like with this machine, I can't get professional results right out the gate, but with a little practice, I feel like I could get pretty good. It was really easy to use. I feel like this is going to be the perfect companion machine to go along with my DIY fiber laser flat cutting machine and my tube cutting machine. This summer, I would like to try to fabricate an electric go-kart using the welder and the tube cutting machine to construct the frame. I think that'll be a really fun project. So yeah, I'm really looking forward to having this tool as part of my arsenal. I want to give a huge thanks to Skyfire for supporting my channel and future endeavors. If you're interested in laser welding, check out their website at ilariastore.com. They have several models available in both water cooling and air cooling types. I'm really looking forward to using my machine on future projects. Coming up next, I've started buying components for my attempt at a DIY SLS metal 3D printer, and there will definitely be welding involved for that project. Don't forget, if you need to purchase laser components for your DIY build, you can get 5% off your purchase if you use the code FROMTravis. Thank you to all my Patreon supporters. I continue to get new members, and on our discussion forum, it's been such a pleasure lately to be able to be involved and see the progress of other DIY builders making their own laser cutting machines.